We are discussing programming in modern C++. Welcome to that. We are in week 8 and going to cover module 39. In the last module, we have introduced templates in C++, that is the backbone of generic programming, meta programming or generative programming, and discussed function templates as general algorithmic solutions for code reuse. Explained templates with deduction for implicit instantiation illustrated with examples. We will continue with that and understand what is class template. This is the outline which will be available on your left as always. Now, before we get into the class template, let us quickly revisit what we have already done. What is a template? Template is a specification of collection of functions or classes. Functions are what you have already seen, which are parameterized by type, not like normal functions which are parameterized by value. So, this is useful for functions which are generically having a common algorithm like search, finding minimum, finding maximum, sorting and so on, but we need to have different versions of those functions implemented for various element types as may be used in those functions because of the strong type checking in C++. Similarly, we can have classes primarily used for supporting data structures, containers most often, like lists, queues, stacks, etc., where data methods and data members are almost the same for all, say, list members, all kind of stacks, but their types, the element types do differ. So, we need to define different classes. So, to work around that, we have seen in the last module that we can have, say, function template. So, to compute the value which is greater of two given values, that is the maximum, we need to deal with integer type values, double type values, string type values, which in C is represented as char star, or maybe user defined type of values like complex. And we have seen that we can do that by using a number of overloaded max functions, and but for each of these type of max function we need to define their body, need to define their implementation. So, these are not only overloaded, but they need separate implementations, and function template is a mechanism by which we can avoid writing their body for each and every type, because all of them use the same algorithm. Finding the maximum of two numbers have the same algorithm, but the code versions are different because the underlying types could be all of these different ones. And naturally, since these could also be user defined types, it is not possible to have such overloaded functions in the library, and user will have to, for each and every type user has to deal with, user has to write own max function. Class template, like the function template was solving, class template is designed to solve similar problems in similar situations. For example, solution of several problems need stack, last in first out container structure, for reversing string or converting infix expression to postfix, to evaluate a postfix expression which could again be done for integer, double, complex and so on. For depth first traversal, we need FIFO or queue for several different task scheduling problems, process scheduling problems and so on. We need list for implementation of several data structures and even for several normal data maintenance activities and so on. So, variety of data structures have common functionality in them, but need to be implemented over and over again because their underlying data type, element type and the associated types differ. So, data structures in general are thought to be generic. They have the same interface, the same algorithm, plus C++ implementations are different. This is the problem which the class template actually addresses. So, just to give you a more concrete example, here we have side by side the stack implementation. On left you have a stack of character and on right you have a stack of integer. So, you can see that these are the 2 points where the code differ. Similarly, when I want to push, I need to push a character to the stack here, whereas I need to push an integer to the stack here. Pop, or for that matter constructor destructor, has nothing different. Pop also has nothing different, but when I do top, I get a character reference, constant character reference here, whereas for a stack of integer I get a constant integer reference. Again, empty does not differ. So, these places, these 3 places where the code differ because the underlying data type in the case left case is char and on the right case is int. So, the question is, can I not replace this char and int by a type variable t? Could I just say that this is t, this is t, this is t. If I write that, this is t, this is t, this is t. If I write that, then the code on the left and the right become identical, and that is the class template. So, all that I do is I make the type a variable and then make an option that when I need a stack, I will tell whether I need a stack of char or of int or of anything else. That is the basic idea of class template. So, a class template describes how a class should be built, its data members, interfaces, supplies the description, definition of the data members using some arbitrary type name, like the t we just saw. So, it is parameterized with type, parameterized member functions, and it can be considered, for example, an unbounded set of class types, because you can have unbounded instantiations for the type t, the type variable, and for every such type you will have a class being generated from the same template. In order to express that, we use the keyword template like we did in case of function as well, and we have comma separated parameter identifiers which are preceded by the keyword class or type name. We have seen this before, which are enclosed between angle brackets, and then follows the definition of the class. And as I said, most often it can be used in several contexts, but most often this find use in the container classes, particularly the ones that we find in the library. So, let us write stack as a template. So, there is no difference. All that is done is, as I said, we have changed these 3 positions to stack to type t, the type variable t. Everything else in this class remains same. I have added a first line which say template within angular bracket class t. This tells that in the following definition of the class, t is a type variable, and whenever I want, I can replace a type for t and get the stack of a specific type. Right? Now, naturally the question is, if t is a type, then what are the properties that t should have? These are loosely called traits. Traits are a big matter of study, but we will just take it in the way that, well, certain properties this type must satisfy to be able to use it as an instantiation type for the class template. For example, we need to be able to do assignment, right. I should be able to assign that. I am doing it here, right, in push. I am taking the item and putting it in the container, where the container here is an array, the actual physical container underlying. So, unless T has a copy assignment operator, I certainly cannot do this. Now, naturally, I have not elaborated, but it is quite obvious that T must have a constructor and a destructor to be able to for me to be able to construct it if needed, and obviously destruct it when the stack is being destroyed all over automatically. So, the array elements will have to be destroyed, destructor is required, but I will point to the special functions or operators that are needed for T. For example, just as a, or rather as a counter example, I would say that, well, I do not need to know if T can be compared or not. Whether given two elements of T, I can say whether they are equal or unequal or less or greater. If I cannot say that, that is, if T does not have any overloaded comparison operator, I do not have a problem of using it as a stack. In some other context, I may have. So, the properties that I need of this type variable T defines the traits of it, and we must be aware of that trait to be able to actually instantiate a class template. So, how do we use it? Once we have got that template defined, as we have done in this header file, we use it in a manner which is very similar to the way we did in case of function. We had function name followed by the type being instantiated with in corner brackets. Here we have the class name followed by the type. So, this defines a stack of character. So, what the compiler does is it sets in that header file code, it sets to char, generates a code which replaces T by char and then compiles it. So, since it generates a code, it just had the template and it is generating the code, this is called generative programming. Since I am programming at a different level than the normal programming where I will know all the types, this is called programming about programming. So, this is called meta programming. So, that is a basic reason for the names, and then I can use that stack as defined as S here, and there is nothing specifically different here. The same code that would have happened if I had explicitly created written a stack of character, I am writing the same code as an application. So, this makes it really convenient to make use of, reuse of the stack template code. In a different context, I am using instantiating the stack, the same stack template code using int. So, T now is replaced by int in the whole of the stack definition, and what you have is a stack of int where every element is expected to be an integer. Then given a postfix expression here, which here I assume that is taken as an array of characters for different constants and different operators, I can go ahead and evaluate it using the stack. All that I need to do is to check that go over this entire array to see that I still have elements, and if I get the element as I get here, then I check whether it is a digit. If it is a digit, I find out its numerical value CH minus the ASCII code of 0, which. So, I am assuming that the constants here are single digit constants just for simplicity, and push that in the stack. And when it is not a digit, it must be an operator like this or like this. So, as I go ahead, I will have things like I will have 1 going in first, 2 going in next, 3 going in next, and then I will have this operator, and when I get that, I will take the top of the stack, which is 3. and take it out, because I know that this multiplication has to happen with the two topmost literals that I have in the stack. Then I again look at the top, I have got 3, I take it out, I have got 2, and then I check what operation I had. I do that in this switch and I push the result of this multiplication, because it is a multiplication symbol. So, now my stack becomes 1 6, and again I have a plus. So, as I have a plus, I will go ahead and do that. I will take this out, add them as 6 plus 1 using this option and so on. So, I can very conveniently evaluate a postfix expression using the stack, where I did not have to write the stack code. I could just reuse the templatized stack through instantiation. So, I already talked about the parameter traits. Parameter types may be of any type, including user defined types. It could be a complex type of stack or a person type of stack and so on. They themselves may be parameterized types, that is, they themselves, T itself could be a template, that it could also be a parameterized type, that is possible. And it must support the methods used by the template functions. For example, does it require a constructor? What are the operator functions required, like stack requires a copy assignment. So, that must be supported by the type that I am trying to instantiate with, right. So, these are necessary traits that my instantiating type must support, and those traits are important to always keep in mind. So, looking back again, how did we instantiate in function? In function template, we used, this is the generic template, can compute max of any 2 values of type T. Then we have specialized it in the instantiation, because for char star, which is taken to be a C string, the comparison has to be done differently. So, we saw that we can specialize it and have a different definition. So, if the function is trying to call by 2 char star parameter, a different definition will be used. And then we have one which takes an array and the size of the array, which is a special type of template parameter, which is not a type, but an integral value which you can also specify for a template. We have seen all these. So, with that, max a b for integer will generate this function, max c d for double will generate a overloaded max function, max s 1 s 2 for char star will use the specialized template function that I have defined. And if I call it with type int and value 7 on an array ARR, or maybe we can use p val here if we are referring to this, then it will bind to this special function which also is overloading max, right. So, this is the basic idea that we have seen, and in terms of class template, this idea will only get extended. So, what I can do is template instantiation is done only when it is required, but I can proceed with just the knowledge that this is templatized class, but without actually requiring its definition, because as long as I do not instantiate it. So, here is one way to write the template as a forward declaration. I say template class T. So, T is the type variable, and class stack. So, which says that class stack is a class named stack which has T as a type variable. Now, with that, if I try to write this, I will have an error. Why would I have an error? Because I am trying to instantiate, but I have not yet told what the class is. I have not yet defined the class. So, this will be an error. This is not permitted. But if I want to define a pointer to it, it is quite okay, because to set a pointer, I do not need to actually know the internals of the class. All that I am saying that the pointer will point to a stack of type character, right. So, that is the difference. So, with the forward declaration, I can, it is okay to write that. With the forward declaration, I can create a reference, it is okay to do that, but with a forward declaration I cannot create an instantiation. And these forward declarations, such declarations are known as incomplete types, because it is telling you part of what the type is, like it is a stack and has a type parameter t, but it does not tell you the details in terms of the data members and methods, right. So, the class template must be instantiated before an object is defined with the class template instantiation, which is what was getting violated at this point. If a pointer or a reference is dereferenced, then also I will need that. Just to define the pointer, I do not need to know the details, but if I want to dereference, then I will certainly need to know the object. So, I need to know the definition of that particular template, right. So, this is the basic idea of class template instantiation, and we will use that in the example now. So, this is a forward declaration, and with that I am trying to use a stack of characters to reverse a string. So, I want to make a forward declaration, I want to write the signature of the reverse string function, and to be able to do that I need this stack type to be known, and I have passing the stack by reference. Note that I have not yet defined the stack class, and it is perfectly okay, because I am just defining a reference. Then again I say class T, template class T, class stack, and I provide the definition. Now, once I have provided the definition, from this point onwards, I can refer to it for defining pointer and reference, but additionally I can actually create objects for it. I can create the instantiation. So, I can create the instantiation here now, and it is going to require this definition which I have already provided. Had this definition not been given, I would not have been able to do this. Similarly, I can implement reverse string function, which is invoking various stack methods, and I am able to do this because I have already defined it. With just the forward declaration, I would not be able to do it. So, that is the basic process of class template instantiation, and you have seen a simple but complete example for that. Now, you can have default parameters for functions, where you can give default values. You can have default parameters for templates also, and those are known as default types. So, I am trying to define here a class student, and the student is, just for simplicity, is expected to have two data members. One is the roll number, which is of type T1, and the other is a name, which is of type T2. What I am going to illustrate is certainly a roll number can be considered to be an integer or a string. Name could be considered to be a char star, that is C style string, or the string type that is given by the C++ standard library, right. So, I have included string as well as C string here. Now, I say that instead of just saying class T1, class T2, I say class T1 defaulted with int, class T1 defaulted with string. So, if I do not specify anything, or if I specify just int, the other parameter, the parameters not specified, will be taken by default. So, if I specified by int and string, this is int, this is string, and I can write this. I can instantiate this object. If I just say int, then the first parameter is specified as int, the second parameter is taken as default, which is string. So, this is specified as int, this is taken as string, though I have not written it as string, and I can construct S2. If I do not specify anything, then both parameters are taken by default. So, I have default of T1 as int and T2 as string. If I instantiate it as string, then T1 is taken as string, T2 is default string. So, in this case I am assuming that the roll number is string, right. So, this is all that I can easily do. Now, with this I can also do a partial template specialization. I did template specialization for function when I introduced max for char star. So, similar thing we are going to do here. So, what I am saying is instead of 2 I will give you one parameter, which is the first one, whereas the second parameter has already been specialized or already been specified to be char star, right. Because as you can understand that when I have the parameter here as string, then at my construction time I need to do a copy construction of string from the given string to the data member name. Whereas, if it is a char star, then if I follow the first definition, I will have an error, because what it will copy is not the string, but it will copy the pointer, right, as we have seen this. So, it will do a shallow copy, it will not be able to do the deep copy. So, I have to have a separate specialization for this template to deal with the second type parameter being char star. And if that is done, then I need to do all this allocation for that string, and then in that allocated area I need to copy the value, that is what I am doing here is necessarily a deep copy, which is specifically required for char star only, right. So, if I instantiate now with student int char star, then int is taken to be T1 and char star let me use the second specialized definition of this template, right. I get, and therefore, if I had not provided this, then doing student int char star would have been an error, because it would have just copied the pointer, not the actual value, and then during destruction time it would have been difficult. So, this is it can be generalized in any ways further, but this is what is known as partial template specialization. Now, finally, before we close, let me take a look at what happens if you do inheritance, because since you have class, you can do inheritance with the template classes. So, what I provide, I could have used the library definitions also from the standard library, but I am just using vector as a basic container, but otherwise I am trying to define my data structure. So, I say I have a list where I will actually keep the elements. My objective is to define classes for maintaining set and specifically bounded set. So, in the list, what do I need? I need a way to add a mechanism. So, which is put, which in terms of vector, because your container is a vector. So, is a pushback. So, that will add an element. So, as if a list is being implemented in terms of an array, something peculiar, but naturally your vector will allow you to do that, as long as you do not want to manipulate in the middle of the list. Then size is simply the size of the vector. Find, we can go along, this is just doing a linear scan and find out if that element exists. If it exists, it will give you true, otherwise it will give you false. And you can see by the side that when I do this, I require the equality operator to be available to compare two values of t, otherwise I will not be able to do this comparison. So, the trait must include this. Similarly, for creating a vector, and vector can expand. So, it might need to copy when it expands. So, I need the constructor, destructor, copy constructor, or move. We have not seen move yet, it will come in C++11 for the list. So, this is my basic container, and with that I will now define what is a set. So, this is my set, which has set the virtual virtual destructor, because I want to make it a base class. I have an add method to add an element to the set, and what is the peculiarity of the set? The peculiarity of the set is it cannot have duplicate. So, I need to use find function to check if the element being added is already there. So, when I try to do add, I first do a find. If it is there, I do not add it, because duplicates are not allowed. Otherwise, I add it by doing the put of the list. Right? This is a simple thing that I do. I can find out the length using the length of the list, which is the length of the vector, and certainly I can do the find using the find in the list. So, this will give me a class to maintain any set using list as a container. Right? Now, I want to have a specialized set, a set where the elements are bounded within a range. So, I call it the bounded set. So, in the bounded set, I have two bounds, lower and upper. So, every element has to be in between that, and certainly I will not allow any element which is outside of it. So, if I want to add an element, I have to check whether the bounds that are given here are satisfied. That is, the value must be less than equal to the max and greater than equal to the mean. Only then the add is enough. So, I need to override the add for the set class. So, this is a polymorphic inheritance, as you have seen, because add was a virtual function in set. So, I override that and I check if it is within the bound. If it is within the bound, then I make use of the add of the parent class to actually do the adding, which finds for duplicate, and if the duplicate is not there, we will put it in the list and so on. Right. So, in this way, using set, specializing from set, I can have a bounded set, and all of these list set and bounded set are parameterized by a type parameter t. So, using that, I can have a set, bounded set of integer defined. I create a pointer to set and let it point here. So, it is doing a upcast automatically of the pointer type. Then it adds, since the actual elements are the actual bounded set is a specialization. So, this add will call the add of the bounded set, and then I can do find directly to see if it is, if an element is within the bound, and then it must be found. If it is added, all values from 0 to 25 have been attempted to be added with the bound of 3 and 21. So, naturally 0, 1, 2 could not have been added, 22, 23, 24, 25 could not have been added. So, this will succeed, this will fail on 0, this will fail on 25, and that is what you get. So, this is a simple illustration for what you can inherit and create a specialized definition from. I am just going back one slide to highlight that here, for example, you are the trait of this type now needs, the set type did not need, because set type is not checking comparison of values, but the moment you make bounded set, you are checking comparison of values less than equal to, greater than equal to. So, these operators, these Boolean operators must be supported by the type T. So, I can have it on int because int has these operators, I can have it on double because double has these operators, but I may not be able to have it on student because I have not defined any such operator. Right. So, this is your basic class template, and with a complete example. I think to summarize, we have talked about templates, the generic programming in C++, discussed the class template as a generic solution for data structure reuse, and demonstrated them also on the hierarchy. We will have lot more examples in our assignments and some in the tutorial. This is a very, very strong area, and we go into the modern part of C++. Discussing C++11 will make use of this concept of template very widely and very rampantly, both for the function as well as for classes. Thank you for your attention, and we will meet in the next module.